Okay.
Got it.
Wait, am I recording? Yeah, definitely right.
Yeah.
For people who are just, I started recording a little late. You haven't missed too much yet. Mark Santolucito is here. You missed a stellar introduction, but he's a wonderful guy. Look him up.
All right, cool. So we're going to talk about this object that will walk through a CSV for us. Nothing super fancy, but really sets the ground for you to do some cool stuff, hopefully. We're going to talk about how that's built just a little bit. I don't want to go into too much depth because I know not everybody cares about that, but I want to keep that door open for you. And then we're going to talk about this changing the number of outlets and the implications of that, which is vast, actually. And then we'll talk more generally about code as an interface to creativity and some of my research and what that means.
I think I know what CSV means, but maybe it's only
Yes, comma separated value.
right.
So a CSV is one way of structuring data.
And actually, I'll be talking about that specifically because there's issues in datasets.
Yes. So CSV, common parlance in the data science world, something you'll get very familiar with through this class, after this object, I guess. Right, and then I'll talk about code as an interface to creativity and some of my own research, which we'll see how that works for you. Okay, so I'm going to do a demo of this object. I also have a video walkthrough of the objects as well. So if you want to go back and learn more about the details of it or review any of this, it's all in this YouTube video. But I thought I'd do a live demo now because that's kind of fun. So let's start with the basic version. Oh, you know what? And let me just first click on this just so that I can
Okay, here's a demo.
show you the links. I should have had these links here, but you can get all the code here. You'll be able to download these objects and all of this other stuff, and there's a little bit of a README here.
I never saw that. I copied your code off the video.
Oh, I'm sorry. That's unfortunate. Well,
that's how I got to learn it.
It's true. That'll teach you. Okay. Well, it's also here. Maybe I should have put that above the show more somehow.
I'll make sure this is linked in the class pages too, and the videos too. It's very helpful.
Cool. Okay, but let's take a look at the demo because live demos are what makes life interesting. All right. So we're gonna start with close this one. This is our CSV reader .js. And now when I say it's a max object that we made, that's a little bit of a lie. Actually, it's a JavaScript object. It's called JS, or it's a max object called JS. And we put code into that object. So it's actually not a unique object. And if we right click on it and do the, what is it, inspector? I don't know, the open JS help, you'll see it's no help about the object that we have in particular. It's just sort of general help about the JS object. So just to be clear, it is a general object that we're loading in a JavaScript file into. And just quickly, I'll show you what happens. Every time I bang this object, I'm getting two values printed out. You'll recall from probably your Max lectures, we print left to right. So we're getting the first outlet here, from symbol plus 10. So from symbol just converts our string to an integer. We add 10 and then we print it, and then we're just printing the other value. Why do we do that? I don't know, it's a demo, whatever. Let me try and figure out actually where the showing file explore that CSV file, test.csv. Okay, and you can see we're getting the values we have the values 1, 2, and 3, 4, and our printouts were 11, 2, and 13, 4. So every time we bang that object, we're walking down the CSV, and every outlet is another column of that CSV. Notice that we skip the headers. So this, the way this thing works, it expects the first line of your CSV or Excel spreadsheet to be some header values. We can take a quick look at the code here. It's not long at all. So, if you're familiar with code, great. If you're not familiar with code, you can do a little Code Academy and get the basics and already kind of know what's going on. So you can edit code in this Max editor thing here just by using the open object and then changing things around. But this editor really sucks. There's just no, I mean, look, they do a lot of things great, but they don't have time to do everything. So instead, what we would want to do is open this up in some other program. In particular, I'm going to open it with Visual Code, Studio Code, whatever this thing is called. This is nice because, in particular, I can zoom in to give you a better presentation. But also, if you were to load in, here, it will give you sort of, you can mouse over and it gives you information about what the heck you're doing, which can be a little handy to do. It's got a little bit of a description here. Read in a CSV on initialization of the object, automatically set the number of outlets based on the number of columns in the CSV, send the value of each column out of the respective outlet index on a bang, and the outlet values are all strings. So why do I write all of this? Well, when we're doing programming, it's very important to document your code. You'll notice what's interesting. This is like the perfect storm of undocumentable code. Max is not so much designed to really be transparent. It's hard to know what's going to come out of these outlets. It just says outlet 0. So it's a bit of a mystery. So having this these little extra documentations just makes it easier that the next person coming along will know how to use this code that you've put together. Okay, so here we're just walking through the file. And if I change this to test2.csv, you'll see that a third outlet has popped up. And that's because if we take a look at test2.csv, we'll see we have now 3 columns. And if I go back to this thing, and well, if I just do this for now, and I bang this, I'm getting 11, the new values. Just clear this out so it's really clear. So that's 13 and 4. We're not getting that third column because we haven't connected it anywhere, but let's connect it up. And now we're getting hello world there as well. Okay, cool. We're going to get back to this idea of adding an outlet because, like I said before, it's really cool. But before we do that, let's see what we can actually do with it, because just printing out values isn't so cool. I'm going to leave the really cool demos to Brad for later. But here's a quick.
haven't seen them yet.
Well, I know they're going to be better than this because this is not. This is really.
There's one that's remarkably similar to that.
Okay.
With the squirrel census.
I see. So here we're using our JS reader again at the top, and it's going to do the same thing. We're going to hit bang, and we're going to print out some values out of these outlets. Now, what makes this a little bit different is there's another object called node.script. What this allows us to do is also wrap JavaScript code into a Max object. What's a little complicated about this is that it's JavaScript code, but it's different JavaScript code. Now it's a node script. If you've hang out with developers, you might have heard of this thing called Node.js. Node.js is a popular framework for making websites, but more generally, it's a popular framework for running heavy lifting computation in JavaScript. So JavaScript originally was invented for the web to run on the client side. That means that it's supposed to run on the end user's computer, somebody who gets on the website and interacts with it. So that means it should be lightweight because that code has to be transferred over the network over and over and over again. And it should not be too computationally intensive because you don't know what sort of computer the other person is going to run their code on. These days, because computers are so powerful and network bandwidth is so cheap, we don't really care. We want JavaScript to do big, crazy things, which it was never designed to do, which does come back to bite us. But for the most part, it's okay. So that's where Node comes in. Again, I don't want to get into the details of this too much, but it lets you write slightly different types of code. In particular, what we care about is this lets us call a command line executable. So here I'm calling the espeak.exe executable. Espeak is a text-to-speech library. Text-to-speech is, we had a nice demo of that at the beginning of class with Siri, which will obviously just speak out text to us. So this actually, there's not a lot going on here. It's just a wrapper to call this command line function. But this is a really nice little chunk of code because you may want to call other command line functions very commonly from Macs, and you can do that with this, which is cool. If you want to import this code, a word of warning, as should be apparent by the .exe extension, this is compiled for Windows, so you would need to get the Mac's executable. So yeah, that's just another thing. Anyway, let's see if this is going to work. No. We should hear stuff, but we did earlier. All right, well, let's skip this one. Maybe this one's just broken. I have the same one, except it reads a different data set. Bother. Just a moment. Ooh, it doesn't like that. Let's just try around.
Hey, can you guys hear Mark on Zoom?
Can you hear hello world?
Can you hear the thing saying hello world?
I don't think so, actually.
Okay. You guys on Zoom? It sounded really cool. Okay, but but you couldn't hear it, I'm afraid.
Oh, now it works.
Oh, wait.
Well, okay, so now you on Zoom can hear me again, but you won't be able to hear Max. I can only have one process eat up the audio driver at a time, unfortunately. So apologies for the Zoom people, but there is that nice video which demos all of this as well.
Plus, I'll be showing some stuff later too.
I think you can hear your microphone maybe.
Yeah, that's true. Yeah, just my.
Let's give it a try. But I think it's still going to kill the whole thing. But we'll try it.
Nice for her.
Yeah. Well, anyway, the point is it's walking through the CSV and reading off those words. Yeah, check out the video, and it's applying reverb as well, just as like a little added bonus. Okay, cool. Well, I don't want to take the whole time talking about this. I want to mention one thing, and then we're going to move on, which is I can change the number of outlets. This is crazy because here's the way we do that. We take the first column of data and split it on the columns to count the number of columns, so we know how many outlets to have. And then we just set outlets gets number of columns, and we can do this. Cool. Not a big deal, right? And then when we want to send something out of an outlet, we just do, here I do for each, which is a loop, and for each value, I send it to the appropriate outlet.
Mark, I got a question
Yeah.
for you, because I was trying to do something goofy. The outlets have to be set when you instantiate the JS object though, right? Because I was trying to change them dynamically and I wasn't able to.
This is
Okay.
true.
Okay.
This is true.
I just want to make sure I wasn't doing something stupid, because I tend to do that a lot.
Yeah, so it will reset the outlets when you change the
Data set.
data set. So this is actually an important distinction, right? Because it gives us almost flexibility. Max almost gives us the ability to create objects with different number of outlets on the fly. It doesn't quite, but still it's quite close. And you could pass in different data sets on the top here probably somehow, and have it reevaluate. So this is what we're doing. This JS object actually is creating sort of like its own meta object, so to speak, that can have a different number of outlets. So some people call this meta programming, or you can call it higher order functions, because it's a function that creates a new function. So it's not a first order, but a higher order function. This is really cool because what it means is that we can apply functions to other functions, we can generate functions, we can do all kinds of complicated stuff that you couldn't do if the only thing you could do was add and subtract numbers, for example. So it's just a start, right? There's a lot more you could explore here, but I want to get to some more examples of why this is really cool. So with the ability to change the number of outlets, we have higher order programming, sort of, in Max. This gives us a new level of expressivity. I'll post these slides as well. So why do we care about the expressivity of our programming language? Don't we just want to do the thing that we want to do and move on, and who cares about code? Well, I like to think about programming language design as instrument design for artists of computation. I use this phrase, artists of computation, very intentionally. Really, I want to think not about artists who are primarily working in a media element, but in a computational element that in many cases has a media element connected to it. So let's think about it like this. If we think about traditional instruments as code, you have a piano. Obviously, you can press the pedals, you can play the keys in particular ways, but more or less, you press the button, you get a note. Then we add extended technique and we expand the range, the expressive range of this instrument. For example, we could open it up and actually maybe somebody here will know. I swear there was a piece where you could, that called for beating the piano strings with a dead fish that I had seen at one point, but I don't know, maybe not. In any event, an example of extended technique where
So Lamont Young feet available.
I think you started out by playing underwater.
So this is extended technique, right? It takes this set of expressive possibilities with an instrument and it expands that set of expressive possibilities. The cost of that at new sound, of course, is, in addition to destroying the instrument probably, it requires more expertise, so to speak, a new way of interacting with that object. This is a monome. It's a step sequencer. Similar to a piano in many ways. You press a button, you get a sound. It requires a little bit more expertise in a technical sense in that you need to upload the certain sound. I want to be clear, I'm putting this on a spectrum. It's not a spectrum, it's multi-dimensional, but let's just, for the sake of the analogy, we can upload lots of different sounds, which gives us a larger expressive space, but again, incurs a higher technical cost. And then all the way on this side, we have programming languages where really we have an infinite space of sounds that we can make, but an even higher technical cost. It doesn't really work as naturally to create sound out of that. So there's this sort of trade-off, roughly. It doesn't really work like that in practice all the time, but let's think about it like that, kind of. And so what I'm focusing on is how do we explore the very end of this spectrum and the space between different programming languages, and how do we design the interfaces for these programming languages to make it more interesting or have different ways of interfacing with the sounds that we make. I don't want to say like better or easier or anything like that, but think of it like a saxophone and a violin, just two different ways of interfacing with the object of interest. So who are these computational artists or artists of computation? A quick intro to live coding. So live coding, or a timely analogy here, how I learned to stop worrying and love making all my compile time errors into runtime errors. So live coding is the practice of writing code in real time as a performance art. So typically what will happen, I'll show a quick video. I think we have time. Yeah, I'll show a quick video of this, assuming the sound works. You get on stage, you write code, and you're basically writing a while true loop, an infinite loop that's looping over and over and over again and playing sounds, and you hot swap the code. So you're changing the code out as it runs to create a different beat pattern. You'll see how that works.
It was just like a loop.
Oh, yeah, just a loop, and you're changing that loop as it runs over time. I'll show an example. But the active programming becomes a critical part of the end product. So it's something that I'm very interested in exploring. Actually, New York had one of the most lively live coding scenes pre-pandemic, and then it all completely died, which is very sad. Okay, so let's just take a quick look at some examples of what this can look like. Let me make sure that I'm sharing my sound. I am.
This is a lot of fun. So if I have a...
No, we can't hear it. You know what I'm going to do? I'm just going to unplug my thing here.
Sample.
Oh, come on, please.
Sorry about this, Mal. I wish we could get in here earlier.
I don't even know what Sony PJ is.
I
I think it's that.
ebit arp. Have I got that in there yet?
Okay, cool. Can you on the other side of Zoom hear me?
Hey guys, can you hear Mark on Zoom? You'll have to speak because we can't see you.
Yeah, we can
Yep.
hear.
Cool. So,
That's built-in sample, and if I can filter it down, get 120 BPM at C minor. Right, this is a standard sample that I've downloaded and bought, but it'd be really fun to be able to mash it around. So if I choose onset 0, it just pulls me the first note, and the second note, and the third note. We count from 0 in programming for some crazy reason. So, and then I can put this in a live loop, which is a way of repeating the thing, and sleep for a short amount of time. This is quite fun, right? That's already going. So now I can start changing this number and exploring the notes. But I can also pick them. So now I have an infinite random stream. And get another live loop. Let's call it beats. And play sample bass drum house. And sleep for half a beat. And I'm going to synchronize this so at the same time with 3. Right, and already this is very, very simple. We can start to see how this can grow in complexity. And then I can say, well, actually, every 8 times, I like to reset the random seeds, which means that I get the same choice. Can you see what I'm doing here? It's very, very simple. Just changing these numbers around. And so at this point, when I practice a couple of hours a day, I just think about, I listen to the music and I think, well, where can I take it? What would be interesting? So at this point I think, well, maybe a more complex beat might work, or maybe some guitar sounds. So for the rest of the 1.5 minutes, I'm just gonna, is it okay? I'm just gonna make some music and just to see where I can take it. I've got no idea. So usually I have another live loop, which is a bit longer. I'm gonna call this Hello. I'm running out of ideas. Sync it with foo, and I'm going to play sample, arrow vein, beats, 24 beat stretch. There's always a nice one to work with, C for 8.
say that again?
What kind of code is that? What language is that he's running?
This is SonicPy, and this is Sam Aaron, the main developer behind SonicPy. Awesome.
Boys, you can type fast.
So this is a programming language called SonicPy. Definitely highly recommend checking it out. Very usable, very easy to use. Another language is called Tidal. I won't show this demo, but I'll show very briefly. Just to show that live coding can take on a lot of different vibes. So obviously this is like more of a basement algo rave, as it's called. So lots of different versions that this can take. Yeah, the guitar samples are pre-recorded but being processed in SonicPy. Okay, so cool. Now we have this idea that there's this expressive space that we can explore with programming languages, and it is sort of its own computational performance object. What are new ways for us to interface with code? Just as people invent new instruments, let's invent new programming languages to explore that space. In particular, I ask, how do we construct computational objects? Why is there so much work to construct computational objects, and how can we make it easier? That's kind of what I'm looking into in my own research, and that question, that's problem statement. Nothing about that is specific to music, but music gives us this fantastic domain area to explore these questions. That if you can answer the question in a context where it needs to work so well that you can be on stage and use it in real time, in my mind, you've then answered the question satisfactorily from a programming languages perspective. So I'm going to show two quick demos of some of my work and talk about it very briefly. So the first one is here. This is a live coding step sequencer. And what we see here is a step sequencer on the right that you might be familiar with, and some code on the left. And we stick them together. So what you noticed when you saw Sam Aaron doing live coding was that everything he did was through the coding interface. That's a powerful interface, but there's a reason that not everybody likes the code. Sometimes it's really fun to work with physical interface as well. And so this work is about exploring how can we join these two together. Now, of course, we could just live code here, but we can also click buttons here. And what you'll notice is that we're generating code automatically. So here we've got what's called program synthesis running in the background to automatically generate the code. So hit play here, and we have this code, and I can edit the code to change the beat patterns that I'm playing. Example. So now I get access to two different ways of interacting with my computational object. I can interact with my computational object in sort of the traditional code editing way, or I can interact with it in the sort of physical way of clicking the buttons. Now the challenge here is that how do you keep these two objects in sync? These are two representations of the same computational object, and if you change one, the other one needs to stay up to date. Changing the code, when you change the code manually, then it's not so hard to change the interface. But when you change the interface, what should the code now look like? And now this is a hard computational problem. I'm just going to give you a quick hint into how that works, how we get this back and forth. The way we do this is we split each track into independent synthesis problems. So we're treating each track on its own. So we're just going to look at this one first. And then we generate example constraints based on the time index and note value. So here I've got a 1 and a 0 and a 1 and a 0. And so I'm going to interpret this track as a function over time, where the index is time and the output is the value that I want. So at index 0, at time 0, I want a 1, and at time 1, I want 0, etc., etc. And these become constraints on some function f. I say, give me some function, come up with some function f that meets the criteria as specified by the way that I've clicked on this interface. Now, this is a very domain-specific problem. So what we're going to do is say, well, all of these ones to the right, I haven't clicked on them, so I shouldn't really think about them as zeros. So I'm actually just going to prune those to make my synthesis problem a little bit easier. I run synthesis. This is like, I say I run synthesis. That's like 40 years of computer science research. But I run this problem, these example constraints, and I get back this code here. This is not code in the language that we want to use. So then we need to translate it into JavaScript, and I lost that slide. But we then just do the translation back from this language to the other language. And that's basically the nutshell. But what's cool here, I think, is that you can see already how there's this really rich problem in computer science that we have to solve, but also it has some very real applications in music. Okay, a quick demo of one other area of research that I'm exploring, which is synthesizing synthesizers. Or really, I should say, synthesizing state machines. So state machines, let me show you a little demo. If you ever take some data structures class, you might run into this. It's called a finite state machine. Finite meaning there's only obviously a certain number of states, and it's there are states play C, play G, and play E are the different states. It's a machine because we operate it. So I can click these are called transitions between the states. So I'll click P1 and can go from play C to play E. And then I will maybe take transition P2, and now I should play a G. Right? And so this is some sort of automated composition machine. If these are probability samplers, then this is a Markov chain, right? Where we have probabilities that are telling us which transition to take. If you've done any sort of automated composition, that would mean something. So state machines are cool because they let us do automated composition among other things. Here, so there's a lot going on here. I won't overwhelm you too much, but here what we're going to try and do is construct a state machine where every state is a different signal processing configuration. So rather than play C, play G, play E, each state is going to be a different configuration of all of these parameters down here. And it's not only going to change the parameter values, it's going to change the way they're wired together. So as an example here, I'll just try I can just generate a random specification. Now I'm doing dropdowns. This is no longer example-based synthesis. This is no longer programming by example. This is programming by specification. So what we're doing is specifying, this is how I want my program to work, rather than writing, this is how the program should work, if that makes sense. I'll click synthesize. You can see how long it takes. It's a fairly complex process to synthesize this state machine. And let's just try and pick out something that is supposed to happen here and see if it actually works. So here, every time I play note 1, the harmonizer should decrease the interval by 1 and decrease the Q value of my filter by 1. So here I have the Q value of my filter. Here's the harmonizer interval. I'm going to make sure to turn these on. I'm cheating a little bit. And note 1 is note 45. Which is A2. So let's find A2. What's this one? So when I click this, oh, you can't hear it very well. But you can see that these, here's the LFO depth, at least you can see moving. If I move this one back here. And actually, that's probably because the filter is on and I'm filtering out my note, but whatever. Right, so let's look at what you can actually do with this if you plan it ahead of time. Does anybody know this song?
Autumn leaves.
Bam, got it. So here we have autumn leaves, and what we would like is to reconfigure our signal flow. In this case, it's really just turning LFO and on and off and FM synthesis on and off. So it's less of a reconfiguration sort of, and more of just turning things on and off. But depending on how you think about it, it could be reconfiguring a signal flow. And we want a system where we can just play the notes and all of these changes are going to happen automatically. Let's listen. Hopefully this works. And listen for these, if you know what an LFO and an FM synth is, listen for these changes. So that was Michelle, actually, Bazarani, student who graduated.
I did a project with him.
Yes,
Yeah, oh,
yes,
yeah.
yes, student graduated last year.
He's great.
So that was him on the keyboard, and he was also working on the implementation of this system. So what we see is, again, our interface here. It's not quite code, but it's not quite a physical interface either. It's somewhere in between. And what the goal of this is really to try and explore this space where the expressive capabilities of our programming language tools give us access to new things or encourage us to think in a different way. All right, so where do we go from here? So there's three main issues that I'm working on right now, really more from a computer science perspective. But one is scale. So that first step sequencer I showed you with the live coding is really cool. You should definitely try it out. Oh, I forgot to show you. There's some demos here that you can see that kind of are more interesting. So you can check out some of these demos for more interesting code. So that's a really cool thing, but if more than two of you try to use it at the same time, it will crash. So issues of scale are, you saw when I clicked the synthesize button, that took a long time. Program synthesis is an incredibly expensive task. You're asking the computer to program itself, so that's not surprising. So how do we get this to work in real time? What's cool is that program synthesis has been around for at least 50 years or so. But the question of getting this to be real time has never really been something that needed to be answered because it wasn't used in a real time context. Music gives us that real time constraint that we actually need this to work. So sort of just more motivation to think about how the arts and music can actually motivate our computer science research. The question of interfaces is important as well. How do we create these specifications? So the specifications with the dropdowns we had before are a bit limited, so we're exploring some other ways of like more dynamic dropdowns. More on that later, or if you want, you can talk to me. Also maybe using NLP so that you could just describe in natural language what you want, have that translated into a specification, and then from the specification synthesize code. So lots of space to explore there. And then a big area for exploration, which Rhea is currently working on, is the area of applications, which is what can we actually do with this? Can we generate code for video games, automated composition, visuals, or pick your poison, whatever you want. So if you'd like to know more about that, just chat with your classmate. And otherwise, please come take a class with me. These are the classes I teach. Computational sound and creative embedded systems are a bit more upper level computer science electives. If you haven't done a lot of programming before, which probably isn't anyone here, but maybe you want an intro to Python class. Computing in context is really awesome. I teach the computing in the arts context, and you can check that out. Methods and problems is if you're excited about the idea of higher order functions and theory and computer sciencey stuff, but you want a fun introduction to it, or so I think, you can take methods and problems, and the website is here, and you can see more of what the lab does here. Thank you, guys.
Cool. Okay, so we're going from the sublime to the ridiculous, as they say. Yeah, give us a second. We're going to switch our computers around a bit.
As we're switching, if anyone has questions.
I have a question about sonifying. So it's a brand new language now based on any existing.
It's a little bit Python-like, so it's white space sensitive. But yeah, that's about the only thing that's similar. I mean, it's not a brand new language. Like, it takes inspiration from a lot of computer music languages, but yeah, I mean, it's a language of design.
It looked to me a lot like Ruby.
Yes. It takes a lot of inspiration from Ruby. Actually, that's correct. Yes. Thank you.
Have you thought about like speech interfaces for music composition? Like NLP style, but then you just.
That's even another layer.
Yeah.
I have not thought about that.
Oh.
That is that goes on the to-do list though.
Yeah.
That would be cool. It said based on Ruby. Thank you, Ben. Yeah. Indeed, it looks like Ruby. It was based on Ruby. Are all sequencers state machines? Yes. Every step sequencer could be modeled as a state machine. A state machine isn't necessary to model a step sequencer, though. A state machine has more expressive power than a sequencer, I believe. I don't have a proof. Oh, and let me stop sharing.
Okay.
Okay, gang.
Oh,
sorry. Hey, can you all hear me okay?
There you go.
Yeah. Okay, you guys can hear me. And I think we can hear you too. Ben, do you want to say something?
Yeah, thanks, Mark.
No, we can't hear you.
That was great.
Oh, I've got to turn the sound back up.
Oh,
Hold on. Okay, now try it. Okay, Ben.
I just said, thanks, Mark.
There we go. Cool.
That was good.
Yeah, I feel badly because Mark actually wanted to come in and set up and check the sound earlier, but we've kind of screwed ourselves at the CMC now. We have classes like booked like almost nonstop here. So there's a class that went to 6, and they actually went to 6:05. So he had like 5 minutes to set this up, and oh well. Yeah, you did great though. Okay, so let me see now. What we're going to do is I'm going to use markup. I have 3 demos to show about doing some data sonification. And like I said, this is actually going to be pretty trivial in terms of any coding, because we've already been through most of the stuff with the chaotic equations and things like that. So this is just going to be using finding the name of the game here is finding data sets and making them in the right format for us to use. Okay, so I'm going to walk you through a couple of those, and I want to thank Steve. He gave me some really great links to a bunch of New York City data. We're going to use one of those data sets in a second. But let me go ahead and, let's see, where am I now? I'm going to share my screen here in a second, but I just want to make sure that I have the stuff up that I need. No, you don't want to see recommendations. That's what you want to see.
I think we already see your screen.
Yes. Now I'm going to share my screen. Okay.
Oh, I see.
Yeah. I'm getting rid of that stuff. Okay. So share screen, there it is. Okay. And share my sound. Make it in stereo. Okay. All right. So here we go. All right, so you guys are seeing my screen, I hope. Okay, that always gets in the way. Okay. Can you see this week 6 thing?
Yes.
Okay. Everybody can see it? Okay, good. All righty. So the first one I want to show you is, it's going to be kind of a standard sort of thing that you might want to think about doing in terms of data sonification. And that is, we're going to look up some weather data, all right? And we're going to take a look at this. And there's this great document that it's a good thing they put it on there, because you go to the national weather site, okay? And some of this stuff is pretty dense to try to navigate, not in terms of like coding or anything like that, but just trying to figure out what the hell is going on, okay? And they wrote this cute document called How to Download Weather from the NOAA website, okay? So there it is. Okay, so let me walk you through it, because it's not quite as bad as you might expect. Okay, let me turn this up a little bit, okay, because I can't read it, I'm old. All right, so here's what you do, is you go to this website. Now, you think, oh, wow, that's in blue, and I can click on it. Well, no, it won't work, because it's changed from HTTP to HTTPS now, okay? So let me go out here and bring up my browser. Get this thing out of the way. All right, and yeah, you see why I was impressed by his ability to type, because I'm ridiculous, okay? So there is the National Centers for Climate Data. Oh, this is going to be great, okay? And look, you can browse data sets and all sorts of stuff, okay? But here's what we're going to do. We're going to follow here. Click on the search tool, okay? So we go down here and we find, oh, the search tool. So we click on the search tool, okay? And then you can select your data type and data set and select daily summaries, okay? So we can go here and we can select daily summaries, okay? And then select the date range, and be careful about this, because yeah, this data set, if you look at it, actually goes back into the 1850s.
Wow.
So if you don't set your range to something more reasonable, you're going to be downloading like terabytes of data, okay? So this is reasonable. It's from the beginning of the year up until like now, okay? And you can search for stations, okay? And this is what I did, was I actually entered in JFK, okay? And I hit search, because I know that JFK has a nice sort of weather station, right? Okay, and look, there it is, yeah, 1948 to 2022. So that was when they started operating the airport, okay? And here's what you have to do with this one. I thought, wow, I can click on it and see the data set. No, they don't let you do that. What you have to do is add it to your cart, okay? So I'm going to add it to my cart. It's added to my request cart. So now I can go over here and click on this cart. Oops. Right, and I select the output, and I want the comma-separated values, okay? And this is where you set the range, and make sure that, like I said, is set properly, because you can go berserk with it, all right? And now, at this point, I would hit continue. I'm not going to do it now because I've already downloaded this thing. And what it does is you give it your email address, and in a little bit, it will send you a notification that your data set is ready, and it will give you a link. Click on that link, and then you can download that CSV. Like I said, I've already done it, so let me bring that up here, and I'll show you what it looks like. This is JFK weather, comma-separated values, okay? So it's a nice spreadsheet. Oh, golly, I have stuff here that I don't really need you to see, but we're going to pretend like you can't see it, okay? Move this over here. So here it is, okay, this nice, okay? And this is Mark said the top row is labels, which is cool, because that's going to be used to determine the number of outputs in our thing. And you can see, look, all this stuff. You can get the snow, you can get the snood, okay? And you kind of figure these out. Somewhere they have these written down, but I never found out where they were. But here's the ones that we're going to look at, okay? The temperature average, we're not going to look at. We're going to look at the Tmax and the Tmin, okay? So what we're going to do is we're actually going to create two different sonifications that use those as bounds for the pitches that we generate, okay? And we have to count over. That's actually, I think, column number 9 and column number 10. Okay. So I'm about to, let's go ahead and set up our max MSP stuff. But before I do that, I need to point something out, okay? Because if I were to load this in now, it would generate an error, okay? And that's because this data set is comma-separated values. So it's counting the columns by commas that are actually in the data, okay? Look at this. This took me a while. I kept getting this weird error about exceeding the number of columns. If I expand this out, look, JFK International Airport, comma, New York. So it was adding an inadvertent column there, okay? Now it turns out that this is pretty easy to fix. What you do is you select all. Where do I select all? Where did I do that? Where did I do that, okay? There's a select all somewhere. Dang. Oh, I hit Command A, okay? And once you do that, then you can go here to edit and you can go to replace. And you can put in a comma and you can replace all of them. And then they magically disappear, okay? So now our data set is pretty cool for doing that, okay? So we're gonna save it, okay? And now let's go out to our max MSP. Oh, shoot. How the heck do I get rid of this? Arg. There it fell. Save all. Okay. All right. Save that. Replace. Okay. All right. Let me make sure that I still have this. Yeah, that's still good. Okay. Sorry about that. Okay. So we're going to bring this back up without the class roster from my music humanities class. Okay. So we've got all this cool stuff. Let's go ahead and create our max MSP patch that'll kind of read this and do what we want it to do. Okay. Let me make sure that I'm doing this okay. So, yeah. Okay. So let's bring up, we'll use max 8. There actually is a difference when I get to one of the demos next week between max 7 and max 8. Okay. All right. So what I'm going to do is create my JavaScript object. Okay. JS markobj.js. Okay. And I give it the data set name, JFK, what did I call it? JFK weather.csv. JFK-weather.csv. Okay. I didn't type it right. I think I need to save this. I need to do all kinds of stuff here. Yeah, I'm in the wrong directory. Let me move back here. What am I doing on time? I'm not too bad. Oh yeah, I'm definitely in the wrong place. We've got to go here, and we've got to go. We're going to call this JFK1.next. You know what? I've got to turn up. Yes. Yeah, you see, because it was like too tiny for me, and my eyeballs were not working. Okay, there we go. So there it is. Okay, it's doing good stuff. All right. Now, in order to sonify this, one of the things that you have to do is to look at your data. And like I said, you know, when we were looking at the outputs of the chaotic equations and the other stuff, it's important to look at kind of what your bounds are, because that gives you the range of things that you're going to be able to use to map onto sound producing parameters and things like that. So I added something to Mark's object here, and it's a message that says find bounds. Okay, and you simply give it the column number that you want. I want column number 9, which is the lower right. Column number 9 is the Tmax. Okay, so column number 9 is going to be our Tmax. Okay, so let me go there, and I'm going to just simply put a print object down here. I still can't see what I'm doing. God, it's been a long day. Okay, there we go. All right, so let me do this. So if I click this, it should give me the maximum and minimum for that column, okay? It says, whoa, so that's the upper. Look, the low is 0. Oh, that doesn't seem right, does it? Look, they're all like, 35, 41, 25. Oh, look here. Somebody screwed up, and they didn't measure the Tmax and the Tmin that day, okay? Well, it turns out there's probably a way to tag these cells in Excel, and I don't know how it is, to say that there's no value here. But the default that it does is it just returns 0, okay? So what I'm going to do is override that default. I'm just going to put in X's, okay? Which means it'll return not a number, and that will kind of like make things happy for this, okay? So like I said, a lot of it is getting the data in the right format. This is one of the things that I had to do this, okay? So I go back to this, and I want to reload the data set. So I'm going to pretend like I've changed the data set by retyping it, okay? And now when I say find bounds 9, it says, oh, it didn't work. Why didn't it work? Maybe I didn't reload it properly. CSV. Huh.
You can try using a compile message.
Oh, wait. I forgot one down here. Okay. Oh, you think that would change it?
I think the compile message will also do the
Reload
same
the thing?
thing as I think so.
Okay. Let me try that. Okay. So on advice of Professor Santolucito here, so if it doesn't work, it's his fault. Okay, compile. Okay, let me see. I was wondering what that compile message was. Okay, so let's try this. Okay. Oh, look, yay, it worked. So there it is. Okay, 21 and 59, and we can then also look at the low temperatures. Okay, click that here. Okay, find bounds 10, and that's 9 and 48. Okay, so cool. Now, here's the thing. I'm noticing something about those numbers. One of the things, like I said, that I wanted to do is to introduce you to different aspects of doing music and how we represent it. And so far, we've been dealing with explicit frequencies. All of the stuff that we did, the Lorentz attractor and all that nonsense and the fractal stuff, we were dealing with direct frequencies. Well, I'm noticing that these numbers are very similar to numbers that Mark was using in his demo. They're MIDI note numbers, okay? Turns out MIDI note numbers, you just assign a number to each of these MIDI notes, and arbitrarily they said 60 was middle C. So these go up to about middle C on the high end. What I'm going to do is I'm going to add 30 to them and bring all the numbers up, and then I'm going to use a MIDI to frequency converter so that we'll be able to then represent this frequency to the instrument that takes frequency, okay? And rather than go through the pain of watching me do all this stuff again, I'm going to bring up the thing that I already pre-made, okay? And it's down in here, and it's this, where is it? JFK Weather Sound 1.maxpat, okay? So here's what it looks like, all right? I've done a couple things. First of all, I'm taking the output from the maximum temperature column and the minimum temperature column. I'm doing that thing where you convert it from a string into a number. We can watch the numbers there. And then I'm saying this is going to be variable number 1. This is going to be variable number 2. We're going to feed it into RTCmix. RTCmix is going to then loop and trigger itself over and over again. Why do I have this nonsense up here? I'll explain that in a second. Let's take a look at it and see what we're doing. It's really simple, okay? I'm simply saying, well, here's the amplitude, there's the envelope. We'll have it kind of start at 1 and then kind of nicely, sharply slope down. So we're creating kind of a fake exponential decay here. And we're using a square wave. We're going to make it like 1.1 seconds long. And here's where I say $1 is the maximum. I add 30 to it. $2 is the minimum. I'm going to add 30 to it. And all I'm going to do is basically generate my MIDI value between those two values. So what this is going to do, as the maximum and minimum changes over time, we're going to hear the notes all become compressed or expanded within that sort of range, okay? And we're going to generate a note every 0.05 of a second, okay? So we're going to get a lot of notes coming out, okay? Now, this trand function is important, okay? that guarantees, it's called a truncated random. That means it will give me just the integer part of the note. Because this would interpret a MIDI note of 62.937, you know, but in this case, I want to hear just like a regular equal tempered sort of scale, okay? And down here is where we convert it from MIDI note number to cycles per second. So we'll hear it, okay? So let's do it. Oh, what's this nonsense up here? Well, I have these going, you know, generating a note every 500ths of a second, you know, so it's like giving us a lot of notes. This is the guy that's going to walk us through the data set. So every 3,000 milliseconds, or every 3 seconds, it's going to generate a bang, and that will then go to the next sort of row in the data set, give me the 2 values. So every 3 seconds, it's going to go through. And I listened to it, and I thought, well, that's kind of cool, but you know what? You can't really hear that big a difference between the days. So I also have the bang triggering this, which is just one of those physical models. It's a model of a maraca, and it's only half a second long. So every 3 seconds, when it changes the day, you'll hear the maraca go like that. Okay, because that's the other part of data sonification. You actually want to hear what's going on. Okay, so let's get this guy going. All right. Oh, and reset, by the way, that will put you back up at the top of the data set, which is pretty trivial code to write, but I put it in. So let's get this guy going. Okay, first of all, let's get our first data coming out. So a high of 53 and a low of 48. Oops. Yikes, that's annoying. Okay, and you guys probably didn't hear it on Zoom, did you? Because I have to do this.
We did actually.
Well, you didn't hear it well. You're going to hear it much better now. Okay, Zoom audio device. Okay, there we go. Damn it. Get this. There we go. Okay. All right, now, let me turn it down a little bit here. Okay. All right, here we go. Can you guys hear that on Zoom? Okay. All right, now, let me start walking through the data set. So I don't know about you, but that's just thrilling, you know. Okay. No, it's not that thrilling, but it does show you that this works. Okay. So I was thinking, well, that's okay, but you know, maybe what I really wanted to do was try to attend to the bounds a little bit more. So I did make a second version of this guy. Okay. I think it's might be here. No, because I'm in max 8 and I'm 8 in max 7. Okay, let me go down here. Oh no, I am in max 7. But let's do this. All right, here we go. Better sound 2.max that. Same thing, only instead of generating a range and choosing a note within that range, I'm just saying, all right, the low note, I'm going to play. The high note, I'm going to play. And here's what's clever. You notice how we've always said 0.5 there, which will put us between the left speaker and the right speaker. 0, the high value is going to go in the left speaker. And 1, the low value is going to go in the right speaker. Okay, so that's a way of kind of hearing it, and it's just so much better. Oops, I forgot to give it its first value. So that was a MIDI note number 0. Okay, here we go. Yeah. Oops. Which is a whole lot better, right? Okay, look, these are demos. Okay, all right. The next one might be a little bit more sonically interesting, and then the last one should be very sonically interesting. Okay, but that shows you, you know, this is kind of like the basic, you know, concept of how the thing works. Okay, I'll put the patches, of course, online along with links to all of Mark's stuff. Okay, but let's go and find another data set. Okay, and let me see. Bring up my little cheat sheet thing here. Yeah. got through all this. Ah, yes. Now, like I said, Steve had sent me, he worked for the census for a while, and he sent me a bunch of stuff from the census. Let's go ahead and say that.
And it's actually on the public basis.
Yes, it's a public output. Okay, let me close this guy off because we don't need it anymore. Okay, and I will show you what I did. I will save that just for the heck of it. All right, I don't know why it always does this, but it always does. Okay, let me go here. Okay, and we're going to go to https://opendata.cityofnewyork.us. Okay. So this is actually New York City data, and I thought, okay, let's do something cool. And where did I go? Yeah, I went to look at their data, because I want to see their data. Okay, so they've got all these new data sets by category. Ooh, the environment. Okay, so I thought, cool, I'm going to do a demo, and we're going to like do something that has a real meaning, like climate change, or impending weather disasters, or things like this. So I clicked on the environment, and what should I see but, wait for it, the Central Park squirrel census. Okay. Of course I had to use that. This is insane. Wait till you see this. Okay, let me go to it. All right, so I'll click on this guy. Do I click here? Where do I click? Data set. Oh, why is it not clicking?
I'm thinking of using manhole cover locations on Staten Island.
Okay, yeah, you can. It's amazing. Why can't I see this? Oh shoot. It's probably because I have like this ancient version of Safari, and it's like not doing the right things. Try this again. Yeah, something's wrong here. Let me try this real quick. Because you got to see this. You won't believe it. Okay. Hold on a minute. Let me bring this down. Is this getting too boring yet? Okay.
The suspense is killing.
Okay. Yeah. Okay. Jeez, what's going on here? It's like, oh, there we go. Okay. Open data. Scroll. There we go. Yes. Click on this. Click on this. Click on this. I'm clicking. Ah. Okay. Well, I had to right down here. Click on it. This says click on it. It says click on it. I'm clicking. Oh, good. There it goes. Oh, no. That's about the squirrels. I don't want to read about the squirrels. I want to actually see the data. Okay. Okay. Here we go. Well, if I can't get this to go, there it is. See, now I can click on it. Okay. So here it is. Squirrel data. It's coming in. Come on, squirrel data. There we go. Now here's what astounded me about this. Okay. Okay. You go down here. Look how many downloads of this. 25,000 people looked at this squirrel data. Yes. Okay. All right. Like I said, I'm not going to go through the process of downloading it, but this one, you can download the comma separated values and all that nonsense again. Okay. But I already have it, so let me just show you what it looks like. Okay. Let's see, squirrels. Squirrels, no commas. So this also had some commas in it, and it's funny because they were not commas like the New York thing. Well, I'll show you the data, and you'll see. Okay, I can show you where they are, and then I'll show you what I did with this, and then we'll do our last thing. All right. So this was the squirrel data. Okay. Yeah. It's the highlight, the primary fur and the highlight fur. Okay. Now notice that they're out there every morning and every evening, and they're counting these squirrels.
Your tax dollars at work.
Yes, I know. I don't know who these people are, but they're insane. Okay. They tell you if they're above the ground or below the ground. Oh, this guy was on a tree stump. This guy was under the tree. Okay. So it's pretty insane stuff, okay? Now, here's the thing. Look very closely because I did get that same error at one point. And if you go down here, I believe, somewhere in one of these columns, people would put gray plus cinnamon, comma, something else, okay? So you have to be kind of aware of that. So I just simply did the entire replacement sort of comma thing and stuff like that, all right? So what we're going to look at is the number of squirrels in a given hectare, okay? And we're going to sonify how that changes from day to day according to this data set, okay? So like I said, I'm not going to type this all through because it's going to be painful. I'm going to bring up the squirrels max pat, okay? And there it is, okay? And that, I think it's number 6, 0, 1, 2, 3, 4, 5, 6. Okay, that's the one that contained it. And I did that fine bounds thing, and I discovered that the upper bound was, I think, 23. All right. So I decided to sonify this in a very different way. Okay, so this is now should be familiar. Go from symbol prepend to var1. That brings us into RTC mix. And look, there's stuff here that you haven't seen before. Okay. First of all, I'm going to sonify it with an FM instrument. Okay. And let me show you that first. Basically, we use this in the Lorenz attractor to have the 3 different parameters, you know, the carrier, the modulator, and then the index. And I said the carrier and the modulator determine the harmonics that were generated by plus or minus, the carrier plus or minus the modulator, carrier plus or minus 2 times the modulator. So we get this huge amount of harmonics, okay? And the index determined how many are there. And I said, well, you can also control that index with an envelope. And what I'm doing here is I'm giving it a frequency of a carrier and the same frequency of the modulator. So they're related to each other on a one-to-one thing. So that means they're going to generate harmonics. And it'll have a nice kind of harmonic-y, pitchy tone, all right? But what is this 8.00 nonsense? Like I said, I want to introduce you to different notation for pitch. The MIDI note number is 1. This is an old system that was developed at Columbia Princeton in the olden days for doing serial work. Okay, it's called active point pitch class. Octave 8 is middle C, 8.00 is middle C, 8.01 is C sharp, 8.02 is D, 8.03 is D sharp, up to 8.12, which is then 9.00. Okay, and you could also make them microtonal. You can say 8.00593 or something like that if you want. All right. But what this will do is give me a nice harmonic sound. And what I've done is I've created an envelope here called the index envelope. At relative time 0, it'll be 0. At relative time 50, it'll be 1. At relative time 100, it'll be 0. So this is going to fade up and fade down. That index envelope is going to control how much of that index value you get. So we'll start with like 0 harmonics. Then we'll go up to 5 pairs of harmonics. Then back down to 0. Okay? And I have another envelope, of course, doing kind of the nice sort of amplitude stuff. And what I just described sounds like this. Yeah, kind of a brassy sound. I thought, well, that's a nice squirrely sound. Okay, so that's what I used. Okay, but here's what I did. I'm thinking, well, I'm sonifying the number of squirrels. What if I let that be the number of pitches? Okay, so I'm creating an array here. All right. And I did the fine bounds, and I discovered that the maximum number of squirrels that they found was 23 in a given hectare one day. So this array has 23 values. And the values are kind of like a nice sort of harmonics minor scale. You know, C, D, E flat, F, G, then B flat. And then I go down a little bit, B flat below C, G below C, F below C. Then I go up a little bit. Okay, so that as I basically, I'm going to use the number of pitches to determine how much of this I'm going to use when I schedule my notes down here, okay? So the number of pitches is what comes in from the squirrel census data. That's how many squirrels are there, okay? And then down here, I just count up for those number of pitches and I schedule an FM note at one of those pitches. That's that phi index right there. So if there's only 3, it'll go just the first 3. If there's 23, it'll do all of them on top of each other, okay? So that's kind of fun because it sounds kind of cool, okay? Let's go ahead and do this, okay? Let me reset this, send out our first one, so we've got a number there. And I didn't set this up to do it automatically because I'm just going to do it by hand. So the first thing we're going to hear is 3 squirrels. Okay, and then we're going to go up 4 squirrels, 8 squirrels, 10 squirrels. They must have eaten all their food. Okay. Ooh, something happened that day. Must have been cloudy. Okay. Oh, they all came back. Okay. Ah! Okay. So again, that's kind of a cute way to hear it. And I thought, well, that's actually kind of musically cute too. So in that case, I'm going to do something kind of musical to it, okay? And the thing to do, of course, to make it sound even better is, well, I'm going to automate it this time, is I added, note the outputs. This is our squirrel producing sound. Is going to the second one, where I'm just going to add reverb. Because that makes everything just sound so much more musical, okay? So I'll click and start that. Get us our first values, start the notes up. I'll go up to 23 because that was so cool. I don't know what happened that day, but they're just having a squirrel party. Okay. All right. So that's the fun. All right, now this last one, I think I've got enough time to do it, is a little bit trickier, okay? And it's actually, I said it was similar to what Mark was showing. This actually is similar to what Mark was showing, okay? With the voice and everything like this, okay? What I did was I looked at, I used Sphere, okay? That's that big analysis program that we developed here at the Computer Music Center that shows you all the harmonics, okay? And let me get you some good data, okay, and show you what you have to do. Oh, shoot. All right, hang on a second, guys. Let's see what happened here. For some reason, this computer not being happy. Plug this in. Okay. All right. Oh, good Lord, I stopped sharing my screen and everything. Okay, let me go back to that. Share sound, cool, life is good. Share. Okay. Participants can now see my screen. Let's see if I have my sound directly. Yes, good, it's there. All right, so I have this, you know, I was just lazy, so I didn't record anything new, but I have this data on here, okay?
Hey, my name is Brad.
Okay. You guys on Zoom can all, yeah, you can hear it, I can tell. Okay, so let me take this, and we're going to analyze it with Sphere. Let me take this, we're going to analyze it with Sphere. Oh, Sphere. 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 You think so? Ah, there you go, you're right. I'm going to blame it on Zoom. Okay. All right, so we're going to analyze. You have to say it like that when you do it. So here we got.
Hey, my name is Brad.
Okay.
Hey, my name is Brad.
Sorry, I didn't mean to hit it twice. Okay. So what you're seeing here is all of the stuff that Sphere found, okay? And I want to show you something that this is kind of insane. You can scroll up, and it finds all that stuff, like all the way up there, okay? All the way down. There you go, there it is. Okay. Oh, stupid Zoom stuff is in the way. Okay, so there's a lot of data there, okay? Now, one of the things you can do with Sphere that people who are doing a lot of spectral work really like to do is that you can export this data, okay? So go down here and you'll say export. But the thing to realize is the export format, okay? First of all, we want it in text because we want to be able to like access it and do stuff with it in Excel. So we're not going to use any of these formats. Those are basically EarCom formats that are binary. And there's two different ways of representing. The partials is, he's going to like write out each of those partials, each of those little squiggles, okay, separately. We don't really want that because we want something that's rather regimented in terms of like the columns. The resampled frames basically gives us a time slice through the data every hundredth of a second. That's what we want. So we've selected resampled frames, and if I say export, okay, it'll give me an option to specify a file, okay, and we'll say hey mono.txt, and I'll say save. Then if we go out here and we get rid of this now, I'm doing pretty good. Okay, and we look at hey mono.txt. There it is. Okay, we can see all of our stuff. Okay, so there's time 0.000, and down here is time 0.01. So this would be insane because each one of these is a separate column. So this would create like, first of all, it wouldn't work because I tried it. It crashes. Okay, there's some upper bound somewhere that's like biting you here. Okay, so this is just way too much data. Okay, so like I said, a lot of the name of the game is learning how to massage the data and get it in the format you want. Well, that's not the format that we want. Okay, so I'm going to just trash it because it's just so annoying. I'm going to trash it because it's just so annoying. Trash. Okay, here's what you can do. Okay, go up here to edit. Select partials below a threshold, okay? What if I select the partials that are below, say, -20? Well, look, a bunch of them turned red, except for some. Now if I hit delete, I can get rid of all of them. And now I've got this, okay? Which is kind of there, okay? All right, let's work with that for now. We're gonna go a little bit higher in a little bit here in a second, okay? So let me export this one, okay? Oh, and it remembered what it was called. So now we have this hey mono.txt, okay? And it's a bit more reasonable, see? 0, 0.1, 0.2, we only have like a few columns there. But to be honest, it does get a bit more intense later on, okay? But it's not unworkable, okay? So we want to bring this into Excel, all right? First of all, we want to get rid of this nonsense here because we don't want that trying to be parsed by Mark's object. So we'll get rid of that, all right? And the other thing is notice that it likes comma-separated values. What's missing from this? Commas. So we do our magic select all. We go to edit, and we go to, where's replace? Find, yes. Yeah, find and replace, okay? So we're going to find, say, spaces, and we're going to replace them. Oh gosh, no, that's not right. Okay. Oh, you know what? I didn't do it with text edit. All right, I'm going to do something really, because I don't know how to use this very well. Okay, here's what I did. Okay, let's go out here. CD sound called data sonification, week 6. Okay, VI hey mono dot text. I'm going to say dot comma dollar substitute space for comma space globally. There you go. Isn't that nice? And for those who are interested, yes, I was using regular expressions because VI is the editor to kill all editors. It shows just how ancient I am. Okay. VI was the editor I used in 1984. So, all right. So we've got this cool thing. All right. Now what we're going to do is we're going to open it back up in our text editor. All right. Because we are going to select the entire thing, and we're going to copy it out. Copy. Okay. And we're going to go to Excel, okay, and we're going to close this off, and we're going to create a new spreadsheet, which I only know how to do by quitting Excel, and then starting it back up. There we go. all right? And for some reason, it doesn't come up on normal, comes up on page layout. So I'm going to select this. I'm going to paste them all in, all right? But your work isn't done there because notice that they're not aligned up with the columns and all this stuff. You've got to do this nonsense. This took a long time to figure out. Go text to columns. And you have to say it's delimited, next, with a comma, next. And then you finish it, and then it turns it into the data we can use, okay? So we're going to do one more thing to this data, and then we're going to take a look at it, and I'm going to bring up my match patch and show you how to do it. What Mark's object does is that it determines the number of columns, the number of outputs on your JavaScript object by the number of columns of the very first entry, assuming that that's going to be labels. Now we could actually go here and create an entry and label all of those, but I'm going to do something kind of quick and dirty because it doesn't really matter. I'm going to go down here and find one of the longest columns, okay? And it turns out, I've done this enough that it turns out to be column number 108 is pretty long. Well, actually, yeah, that goes clear out for a while. So I'm going to simply copy this, okay? Bring it up here, right there. I'm going to select that, and I'm going to say insert the copied cells. So now I have that thing at the top, which will give me all the outputs that I want, okay? So now we're ready to go. And like I said, rather than, spending time now going through this, I'm going to bring this up, and I will bring up my sphere1.max tab and show you how to do it, okay? Oh, so here's what we're going to do with this data, okay? How am I doing on time? Pretty good. Yeah, we're going to make it pretty good. You have to kind of look at it, and Michael Klingbeil, the guy that wrote this, kind of specified out what you're going to see, okay? You're going to see, like, first three sort of columns are like the timing, I think the number of partials, and then you're going to see triples. Partial number, frequency, amplitude. Partial number, frequency, and amplitude. We just want to get the frequency and the amplitude out of this, okay? And here's the problem, okay? This is relatively doable, but it would be kind of painful. Come on. Yeah. We could collect every third sort of output here and make that into a pack or some weird maxness or something like this, and then get it into RTCMix or create like an RTCMix object under every single one of these partials, But I did another modification to the Mark object where I can give it a list out, where it'll go through the entire row and give me basically the entire row as a list, separated by commas, okay? All I then do is prepend a text thing that says array equals, then curly brace, and then I append another curly brace to it, and RTCMix will then see that as a specification of an array that I can then go through and get what I want. And that's what I do here. Okay, so I start at 3 because I'm ignoring the first 3 columns, and then I go through. Remember, look, the other thing that we had to deal with here is that the number of columns is changing as more harmonics get detected by Sphere. So I actually use that value of how many points there are to determine how many I'm going to read from that list, okay? So that's all this loop is doing, is getting the frequency value and the amplitude value, shoving it into a wavetable with a nice kind of like fade up and fade down, playing a sine wave, all right? And let's hear what it sounds like, okay? So basically, turn this on. Let's see, and I will start my metro again. 100. This is kind of slow. So it was the original things are 100th of a second. This is a 10th of a second. Oh, wait a minute. I thought it changed. I thought it was. No, that should be working. Oh. Yeah, here it comes. Okay. So they basically, that's what the original sphere stuff sounded like that I did. Okay. And I can slow it down or speed it up, you know. Okay. But, you know, it's okay, but it's not great. You know, I discovered that I could actually include quite a few more partials and get a better representation of the sound out of it. So I went to the next stage down. I did everything below a threshold of -30, and it kept quite a few more partials there. Let me just show you what it looked like. And then I'll just bring up the patch. We won't go through the whole thing again. Okay? So let me do this, edit here, select partials below threshold. Let's make this be -30. Okay? Get rid of this. And now,
Hey, my name is Brad.
sounds a bit better. You know, it's still not great, but you know, it's like I said, it's a reasonable amount of data to work with. Okay? So let's go here, and now let's bring up our sphere2.maxpack, which has that data set going. Come on. I'm just a graphically challenged guy. Actually, I think I may have a issue happening with my computer here. Okay. All right. Come on, start. Damn it. Oh, that's not going to work. I need to get down into it. Sphere2.maxpack. Yay, there it goes. Okay, so you see it's got quite a bit more in terms of columns, you know, because it's got a lot more data. And that would have been like insane to try and like connect all the RTC mix. So this list out is really doing us a lot of good. So basically, you know, now we can hear it, you know, and it'll sound sort of like, you know. Oh, that's the wrong data set, you know, shoot. There's one that's like not quite as bad as that. Guys, shoot. Oh, that's not good. Yeah, I know. I screwed something up here a little bit, I think. And I might have to wait until next time to make it better. Let's see if there's anything else here that I can look at. No, yeah, I'll show you this next time, but I will give you a hint of what we're going to do, okay? Let me go back to this sphere1.maxpack, okay? Which I have. Basically, I think that was one where I set the threshold too low and I was having too many of them come in and basically couldn't synthesize all of them properly. Okay, let's see now, max. Okay, we'll go back to this, and here's what we're going to do next time. This is the fun part. Look, we have the frequency value and the amplitude multiplier. We can change them, okay? Let's try this. Let's say, what if the frequency equals, let me just square it. What the heck will that sound like? Well, let's find out. Okay, close this out. And let's put this up. Again, this is going to be kind of the low fidelity one, but it'll give you a sense that it's going to sound. Which is kind of cool. Now, you're hearing a phenomenon there that you wouldn't expect. It's actually translating the frequency up so high that it's going above what we call the Nyquist frequency and folding it back over. So that's why you're getting this weird sort of tinkly sound, okay? So that's kind of fun, you know, and if you don't care about actual data, that's kind of cool, okay? Or you can say frequency equals, say, let's see, I times 100. Let's see what that does, okay? So now we put this in, and we'll put that. Yes, that's exactly what it is, actually. Okay, so again, you know, I just thought of those two things off the top of my head. But we could go in and start messing around with the actual pitch data of Sphere as it's being resynthesized, and you could come up with some pretty intriguing sorts of things. Take one of our chaotic equations and chaosify the data, you know. Don't even know what that would be. But anyhow, It's a very powerful tool. So this also, like I said, should show you a bit of how to use these data sets. And, this is, the idea was to show you what we do with local data sets. Now, next time, and I'm really happy because just over the weekend I figured out how to get it to work. We're going to look at streaming data sets. Okay, we've got a couple of things. You're gonna get a kick out of. We talked about this earlier. I'm pointing to Vinay. Vinay works at Mascarani's lab, doing a lot of brain stuff. And I'm going to bring in the brainwave sensors. We're going to look at that data. And Nico's got some really cool stuff to show using data from his Apple Watch. And we'll sonify some of that. And then we'll connect to a real live actual data generating station that's giving us up to the minute reports of the weather. And we'll see what we can do about sonifying that. So, and it's all based on Mark's objects. So you got to thank Mark. Yeah. Anyhow, that's it for now. Let me stop my share and see if there's any questions that I missed in the chat or anything like that.
Spear, where can we get Spear?
Go to the CM. I'll put a link in the thing. Thanks for reminding me. It's on the main CMC website. It was done by one of our graduate students here about 15 years ago, I guess now. It's been a while. Yeah, it's free. It's a really powerful program. Really amazing stuff. Okay. So our state sequencers, should we add in custom outputs? Come on the bottom. Okay. All right. Okay. Any questions or concerns? Everybody doing okay? Should ask that at the beginning of the class. You guys all happy?
So I got one question.
Sure.
Where can I get the Mark object?
Oh, I'll put that on the website too. Okay.
okay.
Or go to the GitHub repository.
I'll send you
Yeah,
this.
all those links are going to be there.
Download it before I use it. Download the package. Is it
All you need is the JavaScript
Oh, okay.
JS. And put that in the same directory as your Maps
Okay.
hash. Then you say JS, name of the JavaScript thing, then it instantiates. Okay. All right. I got to warn you guys. It may not. Usually, I've been able to get these up on Fridays. It may not be until Saturday this time because or Sunday. I'm flying out to Indiana tomorrow to celebrate my mother's 88th birthday. So that was kind of an important thing. Well, hopefully I'll fly out. I don't think the snow's going to be too bad tonight. Yeah, it is cold.
Yes.
Okay. Yeah, and everybody else, take care of yourself. This is like a trying time. I've been kind of on edge all day, like I said, because my son lives in Finland, and the world is really not good right now. So I told my music hum class, I'm sorry, this is the world that my generation left, but you guys will all fix it, right? That was their reaction too. Okay, so we'll see y'all later.